Welcome here at the Bavaria 5G testbed for Industry 4.0 application at FraunhoferIIS in Nuremberg. We have here a lot of technology for positioning and communication technology available, and I'm happy to introduce some of my colleagues with their projects to show you more about the possibilities we have here in this testbed. We have available 22,000 square feet of indoor and outdoor location, as well as a parking lot, and we can test in a realistic environment all the new application that will be enabled by 5G. With me is my colleague Max, and he will give you some insights about the man-to-machine communication with AGV on this show floor. And I hand over the mic to you just a second, so please.
Thank you, Angela. Welcome. So here in our 5G Bavaria testbed, we are working on new applications and new services enabled by 5G. And one of the things that I want to show you today, one of these new services is 5G positioning for industrial applications. What you can see on the dashboard to my left is an AGV evaluation scenario where we put an emulated UE on the AGV that we use to track it based on 5G positioning signals. So in our testbed, we also need a certain infrastructure to do that, and we have G-Node B with 6 transmission and reception points, 6 antennas, and these operate in the spectrum from 3.7 to 3.8 gigahertz. So that's FR1, frequency range 1, and it's also exactly the spectrum that is available, for example, in Germany exclusively for industrial private local networks. So one of the aspects people are usually very interested in when it comes to positioning is the question, what accuracy will be achievable? Based on our evaluation, we can estimate that the promise of 10 to 20 centimeters of accuracy in frequency range 1 with 5G positioning with time-based approaches is absolutely feasible. In this case, we are doing downlink TDOA, downlink processing, but we're also expecting similar results for uplink TDOA. Now, one of the questions that certainly that often is asked right after the accuracy is, what effort do I have to put into my network? What hardware do I need on my shop floor to make 5G positioning work? This is also a question that we are currently working on. But not only about the numbers of antennas, for example, it's also where you place the antennas on your shop floor, which has significant impact, especially on the positioning accuracy and the highest resolution of the position that you will be able to retrieve from it. Another important aspect is robustness. Also a topic we are currently working on. And for that, I would like to hand over to my colleague Christopher, who can tell you more about the approaches that make 5G positioning reliable enough for industrial use cases.
Thank you, Max. Radio frequency signals, no matter if we talk about 5G, LTE or proprietary systems, they are subject to perturbations if the signals travel through the environment all the way from the transmitters to the receivers. Signals get obstructed, they get scattered, they get reflected, and this leads to multipath propagation, which makes it very difficult for us to estimate a correct time of flight, which we need to estimate robust and accurate positions using multilateration or Bayesian tracking filters. While this is not a problem in general, as such situations are rare, we face them a lot more often in industrial indoor environments because we here have metallic surfaces and heavy machinery. This is why we use machine learning approaches throughout our entire signal processing chain. We use machine learning, in particular deep learning models, as an alternative approach that helps us to improve the state of the art. For instance, we can use time series machine learning models, in particular recurrent neural network, to capture complex movement dynamics of objects. If you have an accurate model of an object's movement, you can actually use this information to improve tracking accuracy. What you can also do is you can take, for instance, a set of channel impulse responses that you receive at certain antennas and use these channel impulse responses to directly estimate a position. You can use deep learning models for that, for example. However, as most of you maybe know, deep learning models are very data hungry. So you need a lot of data, which is hard to acquire in practice. This is why we also apply machine learning techniques on a lower level in the signal processing chain. For instance, you can use machine learning to classify if certain signals are non-line of sight or line of sight signals, and you can then weigh them in the estimation of the position. Or, for instance, you can use machine learning techniques to better estimate a TOA, a time of arrival, which we then can use in hybrid positioning filters to estimate a position. Hybrid positioning filters is actually a topic that is heavily discussed in the work of my colleague Jochen.
Thank you, Chris. So we heard that using hybrid signal processing filters, we get not only the signals, but also we can characterize the signals. Line of sight, non-line of sight, how they were propagated, so we know about the channel. This is not only valid for 5G signals, of course. You can do it with almost any radio signals. Like here in indoor environments, you can do it with Wi-Fi signals or ultra-wideband signals too. In outdoor environments, you can, for example, apply it to satellite signals, like from GPS or Galileo. And you can combine, of course, the signals using hybrid positioning filters. In hybrid positioning, in principle, we combine any kind of sensor data and any signal and any information that is available for an application. Imagine, for example, here the robot traveling around. You have onboard sensors like cameras, lidars, maybe inertia sensors, and you can combine the information from that sensors with 5G signals or Wi-Fi signals as told, to get a very robust, very accurate and available position anywhere in the facility. Outdoors, you can combine satellite signals with 5G signals, for example, to ensure the positioning of a forklift on company premises anywhere there, so you can find your assets wherever they are, and you can also have a positioning for the workers around. Well, if you not yet have 5G signals on premise, it's also possible to do simulation of the signals in front. We started there, simulating signals, 5G signals and other signals, doing it with ray tracing or other simulators to ensure before you have it on your premise that the accuracy in the end will be enough. So this is the way that we combine machine learning with hybrid positioning filters to ensure high availability, robustness and accuracy of positioning for many use cases. That's it from my side, so I hand back to Angela.
So I think, or I'm convinced, you get a lot of exciting news and insights from our technology experts here at 5G Bavaria Testbed Industrie 4.0. And if you like to contact us, you find any information about these technology and about the testbed in our web site here at the Fraunhofer Hannover Trade Fair show, or contact us by LinkedIn or via email. We are happy to share this information with you to make product out of this 5G testbed, and with you we will unlock the potential of 5G.